Welcome to the class, my dear students. I hope you all are fit and fine. Today, we will discuss about stoichiometric and stoichiometric calculations. So, first, I will tell you what is the meaning of stoichiometric. Stoichiometric is derived from from words that is stoichion, which means element, and metrion, which means measure. It is derived from two Greek words, stoichion and metron. Stoichion, which means element, and metrion means measure. Now, what is stoichiometry? Stoichiometry is that branch which deals with the calculation of masses or sometimes volumes of reactant and product. So what is stoichiometry? Stoichiometry means calculation of masses or sometimes volumes of reactant and products. Some pronounce it stoichiometry, stoichiometry. Both are correct pronunciation. It is taken from two Greek words. Metron means measure and stoichion means element. So it is that branch which deals with the calculation of masses and volume of reactants and products. So this is your stoichiometry. Now, I will give you one example. With this, you will understand this concept. Suppose I am taking a molecule which combines with B molecule to form A B product. I hope you all are clear about the concept of chemical reaction, chemical equation, reactant and product. What is chemical reaction? In which rearrangement of atoms takes place, or in which old bonds are broken and new bonds are formed. It's the concept from class 10. So here, what is going on? First might be AA bond break, reactant side bond breaks, and they combines to form one product, that is AB. Now, in class 9 or in class 11th also, you learn law of conservation of mass. Law of conservation of mass, what it states that mass can neither be created nor be destroyed. You know this? Mass can neither be created nor be destroyed during the chemical reaction, or I should say mass of reactant is equal to the mass of product. Who is this? Good afternoon, Muskan. Good afternoon, Anushka. Good afternoon, everyone. So, but if you see in this reaction, mass is destroyed, but here two atoms of A combines with two atoms of B to form one molecule of AB. It is not possible in this case. You destroying the mass, but at the product side, it is not equivalent. So for this, we have to balance the chemical equation. You know the balancing you learned in class 10, chapter 1. So here, if I will put 2 here, now it is balanced. It is 1, 1. They combine to form 2 molecules of compound AB. Now, here it follows the law of conservation of mass. And these coefficients, which is used for balancing of chemical reaction, is your stoichiometric coefficients. It is known as stoichiometric coefficients, and we sometimes written as SC. SC means stoichiometric coefficients. For example, I am taking nitrogen. It reacts with hydrogen to form ammonia. Now balance this equation. Here 1 mole of nitrogen reacts with 3 mole of hydrogen and form 2 mole of ammonia. If you will see atoms on both the side, 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. Now, if I will say write stoichiometric coefficients for this reaction, it will be here 1, 3, 2. These are stoichiometric coefficients for this particular reaction. Or in simple language, I will say stoichiometric coefficients tells us the recipe of chemical reaction. It tells us the recipe, how much amount of reactant and product formed during the chemical reaction. It is told by stoichiometric coefficient. The simple term. If it is any doubt in this topic, then please let me know. Stoichiometric coefficient can be represented in so many ways. I will tell you the ways. See, first, I am taking this example. Same example, nitrogen combines with hydrogen to form ammonia. Here, nitrogen combines with hydrogen to form ammonia. These all are gases. First, stoichiometric coefficients in terms of number. Right? Here, 1, 3, 2. So in terms of number, stoichiometric coefficient is 1, 3, 2. Nitrogen, hydrogen, oxygen. Now, stoichiometric coefficient can also be represented in terms of Avogadro's number. My dear student, it is for 1 mole. It is for 3 mole. It is 2 mole. And you know 1 mole of any particle contains Avogadro's number of particles. So stoichiometric coefficient in terms of Avogadro's number. Here for nitrogen it is Na, that is 6.022 into 10 raised to power 23. I am representing you, I am telling you all the ways in which chemical reaction can be represented, because you have to use any one of them in your calculation part. It will be 3 mole, that is 3 into Na. Na means Avogadro's number. And in terms of this, 2 into Na. Fine. Now, if I will ask in terms of mole, it is given 1 mole combines with 3 mole of hydrogen to form 2 moles of ammonia. Now, if I will ask, write in terms of molecular weight, in terms of gram atomic mass or molar mass. You know, 1 mole of any substance is equivalent to their molar mass in grams. So if I will take, it is 1 mole, nitrogen has 14 molar mass, 14 into 2, 28 gram. When 28 28 gram of nitrogen combines with how much? 6 gram of hydrogen. It will form how much? Nitrogen 14 plus 17 into 2, that is 34 gram of ammonia. My dear students, if you will see stoichiometric coefficient in all these three terms, I only put plus sign in this reaction. Because if we are representing any chemical reaction in terms of molecular weight, then only we can show it follows the law of conservation of mass. Here the mass of reactant comes out to be 34 and mass of product also comes out to be 34 gram. I am telling you the very basic things which generally students forget to learn. 28 plus 6, 34. Only in this reaction, I am putting addition sign here. Fine. I am representing stoichiometric coefficient in different terms. Last, in terms of volume. Now, wait. I just wanted to see the students. Any gas at NTP is your 22.4 liter. So if I will ask, right, stoichiometric coefficient in terms of volume, it will be 22.4 for nitrogen, 3 into 22.4 of hydrogen. They combines together to form 2 into 22.4 of ammonia at STP. This is the table which is showing the stoichiometric coefficients in number or mole, in terms of Avogadro's number, in terms of molar mass, or in terms of volume. Till then, is there any doubt? Please let me know. Or if it is clear, raise your hand. Limiting reagent. So, as a name suggests, limiting. Limiting means the thing which is present in less amount than the required. So, next topic is limiting reagent. It is an important topic from CBSE point of view as well as from competitive point of view. Limiting reagent. As the name suggests, the thing which is present in the less amount, or I should say the reagent which is present in the less amount than the required value, or the reagent which actually determines the amount of product during a chemical reaction. I am giving you very simple example of daily life. The reagent which actually determines how much product will formed during a particular chemical reaction is your limiting reagent. Suppose I told you to make 1 cup of tea and your mother has told you the ratio of different constituents present in a tea. For example, I am making milk tea. I am giving you daily life example. 1 cup of milk tea, I am taking 1 cup, around 1 cup milk. I will require 50 gram, around 1 spoon of sugar, plus I am having 50 gram or less than 50 gram, around 0.75 gram of, sorry, 0.40 gram of tea pack, water, and you will get tea. Suppose this is the recipe of my tea, my cup of tea. If I will say, dear student, I am having 1 cup of milk and I am having 100 gram of sugar and 80 gram of tea pack. And milk is still 1 cup. And in your mind, your mother's ratio is set. If I will say, prepare 2 cup of tea, you have required amount of sugar, you have required amount of tea pot, tea pack, but you are short with milk. You are having less amount of milk. So how much product you will get out of 2 cup? You are able to make only 1 cup of tea. So this reagent, which is present in less amount during a chemical reaction, actually determines the amount of product formed after the reaction. So if I will say your desired product is 2 cup, but you are having less amount of milk, that's why you only make 1 cup of tea. So it is the limiting reagent, and those reagents which are present in more amount is your excess reagent. As the name says, which is present in more amount than the required one is your excess reagent, and the reagent which actually determines the amount of product formed during a chemical reaction is your limiting reagent. I'm giving you one example. Suppose I will say A combines with B to form product C. Fine? Or I will say 2C. If I am giving you 10 molecules of A and 50 molecules of B, and I will ask how much C will form, what will be your answer? What will be your answer? When it's 10 combines, it has more compounds, because B is excess reagent. It will left unreacted during the chemical reaction. It only combines with 10 molecules of A to form 2 of, or I should say 20 of C. Clear? Because it will left unreacted during the chemical reaction. I will explain you this thing by taking one example. Suppose I am saying 2 molecules of A, take out your practice notebooks, which combines with 3 molecules of B to form 4 molecules of C and 5 molecules of D. This is the balanced chemical reaction. For doing problems of limiting reagent, first your equation should be balanced. If the amount of A is 10 moles and B is 50 moles, then find out the limiting reagent. I'm writing as LR, and how much, and find out the concentration or amount of, find out the moles of C and D. Find out the moles of C and D. First read this question. 2A reacts with 3B to form 4C plus 5D. If A is equal to 10 moles and your B is equal to 50 moles, find out the limiting reagent and moles of C and D. One thing always remember, problem of limiting reagent always wins when there are at least minimum of 2 reactants. Because in case of single reactant, there will be no limiting reagent. It always comes into consideration when there are 2 or more reagents. Second thing, any one of them may be present in limit. If they are not present in limit, then it is not the problem of LR. Because sometime in questions, in your CBSE questions or competitive questions, they only ask, tell us whether it is the problem of limiting reagent or no. So first in this problem, because right now I'm taking the topic of limiting reagent, so you think this is definitely the problem of limiting reagent. But in exams, you are not sure. So first, our priority is to check whether it is the problem of limiting reagent or not. It is the problem of limiting reagent or not. How you will check? See, calculate the stoichiometric coefficient of A to B. Suppose, calculate their number of moles and stoichiometric coefficient. Number of moles is given to us. Stoichiometric coefficient for A over stoichiometric coefficient of B. It should be equal to number of moles of A over number of moles of B. First calculate this. This is a very short trick to check whether it is a problem of LR or not. It is 2 over 3 is equal to number of moles 10 by 50. It nearly comes out to be 1 by 5 or it will be 0. Solve it. It is 2 by 3. It is 1 by 5. If in case this ratio is equal to each other, if in any case this ratio is equal to each other, then it is not the problem of limiting reagent. But if these two ratios are not coming equal to each other, then it is definitely the problem of limiting reagent. So first step we have clear, it is definitely the problem of limiting reagent because their ratio is not coming equal. What I did, I take stoichiometric coefficient of reactant over their number of moles ratio. First I have checked, it is the problem of limiting reagent. Next, check out the limiting reagent. I want to check the limiting reagent. How you will check? A is 10 moles and B is 50 moles. Check out their N by stoichiometric coefficient. For A, number of moles is 10 and stoichiometric coefficient for A was 2 in this particular question. It comes out to be how much? 5. And for B, the number of moles are 50 and stoichiometric coefficient was B because the reaction is this. It nearly comes out to be 16 point something. Now, whosoever ratio comes out to be lowest is your limiting reagent. In this particular case, this number is less than 16. So for that particular reaction, A is your limiting reagent. Now please tell me, message me, who will decide the product concentration? Either A or B. Message me first. Firstly, message me Who will decide the yes, Garv Kathuria, very good. A will decide the concentration of product. Now simple, how you will calculate? First I am calculated the concentration of C. Take N by SC. It is the very easiest way to calculate the concentration. Na over SC of A and C over stoichiometric coefficient of C. We have to calculate the number of moles of C. I know the stoichiometric coefficient. It is 4 because you see this. It is 10 by 2 into 4. So it comes out to be 20 moles. Why I have taken A? Because A decides the amount of concentration of C. Like this, please calculate the concentration of D and let me know the answer. I will check who will give me the answer fast. Like the same way. Na over SC of A is equal to what? ND over stoichiometric coefficient of D. I will check who will answer me first. Very good. Sanya, 25 moles. Correct. It is 10 over 2 into 5 is equal to ND. It will be 25 moles. My dear students, in the today lecture, we have discussed about stoichiometric coefficients, stoichiometric and limiting reagent. Stoichiometry is that value which tells us the number of reactant or product. Fine. Then we have discussed the stoichiometric representation in terms of number of moles, in terms of weight, in terms of molecular, etc. After that, we have taken into consideration the concept of limiting reagent. Limiting reagent is that reagent which actually determines the concentration of product during a reaction. Next, we have taken one example. So, in that example, first always check whether it is the problem of limiting reagent or note how you can check. We will check by taking stoichiometric coefficients of different reactants over number of moles. If this ratio comes out to be equal, then it is not the problem of limiting reagent. If it don't come out to be equal, then it is the problem of limiting reagent. Then check who is the limiting reagent. Then take number of over stoichiometric coefficient. Whosoever ratio comes out to be less is your limiting reagent. Then calculate the amount of product or moles of product whichever asked in the question. I hope it is clear to you all. If still any problem, then please let me know.